Hello children, when we are changing a recurring decimal that begins with a whole number, then we check mostly the digits that are recurring behind, and we try to identify whether it falls under a single digit recurring decimal or a double digit recurring decimal, or more than that. For example, if we have 2.333 recurring, it means we have a whole number in front of the point, and behind the decimal point we are having a recurring digit which is 1. So in this sense, we have so many methods we can use, but the basic one is to separate a whole number from the repeating decimal. So what we can do here is to get our 2, which is a whole number, and just add 0.33, which is recurring, 0.33, which is recurring. Since the recurring digit is 1, the bar will be put above only 3 to mean recurring. So in this way, you can simplify your working. You deal with only the repeating decimal while putting the whole number at the side, which we can add at the end. So ignoring it to putting it aside in a box somewhere, we shall have to name the fraction which is represented by this. Let the fraction be m. Which fraction? 0.3 bar. Just remember in our first example, 0.3 bar, which means recurring, will be the one which will be equivalent to m. M is equal to 0.3 bar. We shall call this one our equation 1. We shall follow through the same steps we followed through when we are handling a single digit recurring decimal. We need a point to go behind the 3 to separate at least one recurring digit from the rest. So when we do it, we shall multiply by 10 on both sides. So I'm seeing myself multiplying 10 on this side of m, which is equal to 0.3 recurring, also multiplied by 10. In this we shall get 10m, which is as good as 3.3 recurring as equation 2. What you should not forget is that we have a whole number kept at the side, which we shall add at the end. So the next step, of course, is subtracting, as we have always been seeing. Subtracting equation 1 from equation 2, Roman 2. Equation 1 from equation 2. So we write the second equation, which is 2, 10m, which is equivalent to 3.3 recurring. We are taking away equation 1, which is m, being equivalent to 0.3, also recurring. We start on our left. I have 10 mangoes. I'm taking away only 1 mango. This gives me 9 mangoes, or 9m, if I take m for mangoes. Then this side, we are subtracting from our extreme left, not like what we do in ordinary numbers. 3 take away 0 is a 3, and a decimal point is replicated, then here a 0. So 9m is as good as a 3. We shall divide both sides by 9, you remember, and we shall have m alone as by 3 as a third. But to get the fraction we want, we must remember that we had our whole number we kept at the side. So we shall say, therefore, our 2.33 recurring is as good as getting 2 and we add it to a third. When you are adding a whole number to a proper fraction, it is the same as removing just the plus sign and you have it considered as it is. So when you remove just the plus sign, because we are adding a proper fraction to a whole number, we shall have this as 2 and a third. So 2.33 recurring is the same as 2 whole number and a third. The activity will be done to practice and get many of these, such that when you do, you send back and we mark and then we give you the feedback. Thank you.